Ever wondered where we all came from? The origin of the universe is a mystery that scientists are still trying to unravel. We've all looked up into the night sky, gazing at the stars and galaxies far beyond our reach, and pondered the question, where did it all begin? The most widely accepted answer to this cosmic conundrum is the Big Bang Theory. Picture this: around 14 billion years ago, all matter, all energy, everything that exists was compacted into a single, infinitely small point. Then, in less time than it takes to blink, this point exploded. The universe expanded, cooled, and eventually formed into the galaxies, stars, and planets we see today. But the Big Bang Theory isn't without its mysteries. For instance, what caused the Big Bang in the first place? What existed before it? And why did the universe begin to form structures like galaxies and stars instead of remaining a uniform soup of particles? These questions are important because they help us understand the fundamental nature of our universe. Just like knowing our personal history helps us understand who we are, understanding the universe's origin gives us insight into the basic laws that govern everything around us. Moreover, the answers to these questions could revolutionize our understanding of physics. For example, if we discover what caused the Big Bang, we might uncover new laws of physics that could potentially lead to technological advances we can't even dream of right now. So while we have a general idea of how our universe began, there are still many unanswered questions. Each discovery, each new piece of the puzzle, brings us closer to understanding the full picture. But, as often happens in science, each answer also brings with it a host of new questions. So, the Big Bang Theory, while widely accepted, leaves us with more questions than answers about our universe's beginning. And that's what makes the mystery of the universe's origin so intriguing and exciting. So let's keep asking, let's keep exploring, because who knows what we'll discover next. Imagine something that you can't see, touch, or detect, yet it makes up about 27% of the universe. That's dark matter for you. Dark matter, much like the perfect cup of coffee or the appeal of reality TV shows, is a bit of a mystery. It's a hypothetical form of matter that we believe exists, not because we've seen it or touched it, but because we see its effects on the universe around us. Let's think about it this way. Imagine you're in a room with a ghost. You can't see the ghost, but suddenly, a vase on the table lifts into the air and smashes into the wall. You didn't see the ghost, but you saw the effect of the ghost's actions. That's how we know dark matter exists. We see its ghostly effects on the cosmos. We see galaxies spinning at speeds that should tear them apart, yet they hold together. We see light bending in ways that can only be explained by the presence of a massive invisible object. These are the ghostly actions that lead scientists to believe in dark matter. But don't get it twisted. Scientists aren't just sitting around waiting for dark matter to show up for tea. They're actively hunting for it, using ingenious methods and experiments. They're burrowing deep underground, building detectors in the hope of catching a glimpse of this elusive stuff. They're even using the International Space Station to detect particles that might be related to dark matter. Yet, despite these Herculean efforts, dark matter continues to play hard to get. It's like the universe's most elusive celebrity, always managing to avoid the paparazzi. But that doesn't deter scientists. In fact, it spurs them on. After all, who doesn't love a good mystery? So here we stand, at the edge of our understanding, peering into the shadows, searching for the unseen. While dark matter continues to elude us, its existence is a crucial part of our understanding of the cosmos. Life, as we know it, is incredibly complex. But how did it originate in the first place? This is a question that has puzzled scientists for centuries. Theories abound, each more fascinating than the last, yet the answer remains elusive. Let's start with the theory that has been around for a while, the primordial soup theory. This idea suggests that life began in a warm pond or ocean as a result of a reaction between molecules that contained carbon and other elements. These molecules were supposedly energized by lightning or sunlight, leading to the formation of more complex molecules. This process eventually resulted in the creation of the first life forms. Quite a dramatic beginning, isn't it? But there's another theory that's equally captivating: panspermia. This theory posits that life didn't originate on Earth at all. Instead, life or its precursors might have been transported to Earth from somewhere else in the universe, a step perhaps through comets or meteorites. This idea is like the ultimate hitchhiker's guide for microscopic life, traveling across the vast expanse of the cosmos. However, these theories, while fascinating, also highlight why this question is so difficult to answer. The conditions on early Earth were vastly different from what we see today, and replicating those conditions in a lab is no easy feat. Moreover, the timescales involved are so immense, it's hard to even wrap our heads around them. And then there's the question of what it means for our understanding of life. If life originated from simple organic molecules, it suggests a certain inevitability to the existence of life in the universe. If, on the other hand, life was a cosmic hitchhiker, then it implies that life might exist elsewhere in the cosmos too. Either way, the origin of life is an essential piece of the puzzle in our quest to understand our place in the universe. The origin of life remains one of the greatest unsolved mysteries in science, a riddle waiting to be solved. Life existed for billions of years as simple organisms. Then, about 540 million years ago, it suddenly exploded into a vast array of complex forms. But why? Welcome to the mystery of the Cambrian explosion, a pivotal event in the history of life on Earth. For the uninitiated, the Cambrian explosion refers to a relatively short period in Earth's history when, in a blink of the geological eye, life on our planet diversified dramatically. Picture this: before the Cambrian period, life was pretty much a one-note song. All you'd find were simple, single-celled organisms. Then, bam! Within a few million years, the oceans were teeming with a variety of complex, multicellular life forms. But here's the conundrum. Why did it happen so suddenly? Why did life decide to put on a firework display of diversity after billions of years of simplicity? This is the Cambrian explosion puzzle, a question that has had scientists scratching their heads for centuries. Several theories have been proposed to explain this rapid diversification. Some suggest a sudden increase in oxygen levels in the atmosphere. Others propose that the development of predation pushed evolution into overdrive. There's even a theory that a rise in sea levels created new habitats, encouraging diversification. But the truth is, we're not entirely sure. This event's importance can't be overstated. The Cambrian explosion essentially set the stage for all future life on Earth. It's when most of the major groups of animals first appeared in the fossil record. It's the Big Bang of biology, the genesis of complexity. Yet it remains one of the biggest puzzles in evolutionary biology. Here's where we are now. We know something extraordinary happened 500 million years ago. We have theories, lots of them, but we're still far from a definitive answer. The Cambrian explosion, a pivotal event in Earth's history, remains a puzzle that scientists are still trying to piece together. So there you have it, 4 of the biggest unsolved mysteries in science. We've journeyed through the cosmos, pondered the enigma of dark matter, dived deep into the origins of life, and explored the sudden burst of biodiversity during the Cambrian explosion. Each of these mysteries, in their own way, continues to baffle and fascinate scientists around the globe. Now, let's take a moment to reflect on these scientific conundrums. The universe's origin. That's quite a big one, isn't it? We've come a long way since the days of thinking Earth was the center of everything, but we're still far from understanding how it all truly began. Then there's the elusive dark matter, a cosmic ghost, if you will, that despite making up about 80% of the universe's mass, remains unseen and undetected. And what about the origin of life? From simple molecules to complex organisms, the leap is tremendous. How did we get here, and could this process be happening elsewhere in the universe? The Cambrian explosion, too, leaves us with more questions than answers. Why did life's diversity suddenly skyrocket 500 million years ago? Was it a gradual process we can't see in the fossil record, or did something trigger this rapid evolution? What do you think? Do you have any theories of your own? We'd love to hear your thoughts and ideas. Science, after all, thrives on curiosity and collaboration. And remember, there's no such thing as a silly theory. Even Einstein's theory of relativity seemed outrageous at first. So keep those gears turning, those neurons firing, and continue to marvel at the mysteries of our universe. If you've enjoyed this journey into the unknown, please like, share, and subscribe to our channel. we'll be bringing more of these scientific puzzles your way. Remember, every question we answer leads to new mysteries to explore. So keep questioning, keep exploring, and stay tuned to Quantum Writer Verse for more fascinating insights into the world of science.